Hello everyone, I am Suchita More. Welcome you all in the video lecture on the topic inverse J transform by residue method. Now J transform is defined by the formula J transform of f of n equal to summation n equal to minus infinity to infinity f of n j to the power minus n equal to capital F of j, and J inverse of capital F of j is defined as f of n. If the formula is this, Z transform of 1 or u of n, its value is z upon z minus 1, then Z inverse of z upon z minus 1 equal to 1 or u of n. We we can write all the formulas in this form. Now inverse Z transform. Inverse of capital F of Z we can find out by different four methods. First is partial fraction method, second is convolution theorem, third is residue method, and fourth is power series method. In this video, we are going to discuss third method, residue method. For this residue method, we have to find out the value of residues. Now, how we find out the residues? Now, here in this method, f of z is given. Now, we have to find out the poles of this f of z by substituting denominator term equal to 0. And we consider here all the poles lies inside the circle or inside the contour into closed curve. Then f of n equal to z inverse of capital F of z equal to sum of the residues of this term z to the power n minus 1 capital F of z at these poles. In residue theorem, here function of f of z is given, but here we consider z to the power n minus 1 f of z term. This is the most important point here. Now, how we find out the residues now? Now, there are two formulas for finding residues. First is residue at simple pole. That means its order equal to 1. At z equal to a is given by residue equal to limit z tends to a, z minus of a, z to the power n minus 1, f of z value. Here also we write down z to the power n minus of 1 into f of z value. Then second formula, residue at the poles of z equal to a of order r is given by residue limit z tends to a, here 1 upon r minus of 1 factorial, r minus 1 derivative of d by dz of z minus of a to the power r, here again z to the power n minus 1 f of z value. Now by applying this formula we find out residue and substitute in the formula of residue theorem and find out the required z inverse value. Now we discuss problem on this. Here example number 1, using residue method, find z inverse of 3z upon z minus 1 z into z minus 2. We consider the value of f of z, find out the poles of the integrand by substituting denominator term equal to 0. Here z minus 1 into z minus 2 equal to 0, therefore z equal to 1 and 2. All the poles lies inside the closed curve C, therefore we consider z equal to 1 and 2 are the simple poles, non of order 1 only. Therefore, we apply here first formula for finding residue. Residue of z to the power n minus of 1 capital F of z value at z equal to 1. Its limit z tends to a is 1 here, z minus of a, z to the power n minus 1 into f of z value. Here z minus 1 get cancelled. Now substitute the limit z tends to 1, we get its value minus 3, gives equation number 2. Now similarly we find out the residue of z to the power n minus 1 f of z at the pole z equal to 2. Here by same formula, here z minus 2 get cancelled and here we reduces to this value and now substitute the limit z tends to 2. We get 3 into 2 to the power n gives equation number 3. Now by using residue method, this is the formula. We substitute the values of the residues and write down the required result. This is the Fn equal to this value. Now we discuss another example, example number 2. Find the z inverse of z cube upon z minus 2 whole cube. Here, region of convergence mod of z greater than 2. Use residue theorem. Now here f of z we consider this value gives equation number 1 and we find out the poles of this integrand, that means z minus 2 whole cube, its value equal to 0. Therefore z equal to 2, 2, 2 of order 3. Therefore poles of are z equal to 2 of order 3. Now order 3, therefore we apply here second formula for finding residue. Therefore, here limit z tends to 2, 1 upon r minus of 1, r is here 3, then r minus 1 derivative of this function. Therefore, r minus 1 that means 2 here, then z minus a into to the power r, then z to the power n minus 1 f of z value. Here this z minus 2 whole cube term get cancelled. Here we differentiate the terms these two times and here 1 by 2 factorial which is the constant value. Then we can take this out of limit and then substitute the limit z is to 2. Therefore here derivative of this first derivative is n plus 2 into z to the power n plus 1 and second derivative is n plus 2 into n plus 1 z to the power n, and this is the residue of the terms. Lastly, here only one poles, that means z equal to 2 of order 2. Therefore, we here sum of the poles, that means here only one value, 1 by 2 factorial n plus 1 into n plus 2 into 2 to the power n. This is the value of f of n. That means z inverse of capital F of z. In this way, we solve the problems of inverse Z transform by residue method. If there is a combination of one simple pole and another pole is repeated value, then we take the lastly the sum of this and we get the required result. These are the practice problems. Thank you.